Hello everyone, this is Darren here with Creativity Unleashed, and today we are doing another review. I've got another one of Tooliom's welding machines. This is their TL-200M, which is a 3-in-1 welding machine. So this machine I purchased for around $220. I'm running 7018 1/8 inch electrodes on 120 volts. I'm in a pretty remote location in the mountains. There was no 240 volt available. It is very particular about its arc lengths. It will not run 6010. I don't think it'll run 6011, but 6013 and 7018s, it runs quite well. I mean, all things considered, if you get a bit of a long arc at all, it will go out. So it's definitely a challenging machine to run 7018s on, but it was painted material, and it was kind of hard to clean it extensively well. I had the machine set at what is claimed to be 140 amps. I don't think it was quite keeping up with that. It's probably more like 120 it seemed, but still putting down perfectly acceptable beads. I think it's primarily a MIG welder and flex core welder though. 120 volt power adapter, and then this is your, of course, your 240 volt connection. The electrode holder is a little lighter than I would prefer. Gas hose here with like your standard regulator connection, and also connects right to the back of the machine. Here's something you may find interesting. If you want to run straight CO2, they sell an adapter that this connects to a CO2 tank, and then this will allow you to use the more traditional regulators that run either argon or an argon CO2 mix, and they're a more common regulator. The ones that already have the CO2 connection in America seem to be a little harder to find. Just be careful not to lose your nylon O-ring that's used to connect to the tank. So the MIG gun right here on it is definitely ergonomically comfortable. Uses standard consumables of just the basic cheap ones that usually work fine. All right, so this is where the MIG wire goes, and it comes with this adapter, which allows you to put on the larger 11 pound spool. This here is solid wire. It looks like it's copper coated. This is like 70S-6 wire, which is like your standard MIG welding wire, but you have to use either CO2 or usually an argon CO2 mixed gas for welding when you use solid wire. If you're going to run one of these smaller spools, you don't need this adapter. You can put this straight on. You always, of course, want the wire to feed from underneath. All right, so we're putting in the larger washer, smaller washer, spring, and then the nut. All right, so you usually want just a slight amount of tension so that it doesn't free spin enough where it could spring out and like fill the whole compartment with wire. And so usually, especially while you're getting started, when you're loading it, it'll tension it up more so that it doesn't free spin super easily. You want it to be able to spin, but you don't want it to spin too easily, or you may have an issue. All right, we got that in, and now we'll tighten it on. Make sure that your MIG gun has its consumable end taken off before trying to feed the wire, so we're going to do that now. All right, this MIG nozzle screws off. Some just pull off and have like a spring holding them in place, but this one screws off. This one's a little too tight to just get with my fingers. This does have a flat spot machined on it, so that makes that one easy to come off. Let's see what size they put on here. This is 030, which is cool because that's the wire size I was going to load onto it. So the 030 is 0.8 millimeters, so we'll use that side. So just line up the keyway with the key, and a little bit of working, it should get on there. There we go. This is always a little finicky to put these things together. Definitely helps to have smaller fingers. All right, I'm just going to cut off the part that's kinked. And remember to keep hold of the wire at all times, or this thing will spring and go flying everywhere. feed it through there. And then you're going to want to make sure you feed it into the little hole there. It's easier said than done always. Oh, there we go. So now you can see it's fed into there and it's inside of the groove. So then we can drop this out of the way, push that up and lock it in place. This knob here controls the tension for the feeding of the MIG wire. So now that we have the machine turned on, we're going to want to make sure we're in MIG welding. And so we have our modes. Right now we're in stick welding. Yep, we're on CO2 100%, 030 or 0.8 millimeter wire. And screw on our nozzle and trim off the extra wire. You can of course do the same procedure with your dual shielded flex core. You're just going to want to use your gnarled drive roller. Now we're going to connect the gas connection. One thing to make sure is never to let these scrape or hit the ground. If you scrape this edge up, you can leak gas and that can cost a lot of money over time. This happens to be a 19 on here, and this one happens to be a 17, and we'll snug it up here. All right, so it comes with like a quick guide that helps you to set up what you're doing. And of course here on the top, it provides you like the gauge and millimeters of the thickness of material you're working with. And then you can go down and look at like recommendations for what you're doing. We're using of course solid wire, and I'm planning to weld around the 13 to 16 gauge. So there, I think we'll start with 16 gauge. So it recommends 99. What you'd normally set, whatever your voltage is, but on this, it just has low, normal, and high. And so that would essentially be setting your voltage. This is the part that powers your MIG gun. And so you can choose whether to do direct electrode negative or direct electrode positive. And they say to use direct electrode positive for our solid wire. So then we've connected it there. Ground to the negative. And if you're doing flex core, usually it's opposite of that. All right, I'm here at the gas regulator. This one's a Harbor Freight one. Isn't particularly the nicest. Usually they say it's from 15 to about 25 CFM. You can release the wire tension so it won't feed. Make sure you're not touching anything metal. And you can purge the machine. You'll feel the shielding gas coming out here. And you just want to purge all the air out of the line so that when you start welding, you don't, of course, get a lot of porosity. So, of course, it's also a good idea to treat your nozzle with some kind of anti-spatter spray. You just get a little light coat inside of it and around it. And that will help keep the spatter and all from sticking and keep your MIG gun looking nice for longer and easier to clean up. So I'm just using a Lincoln Electric Viking 4C welding helmet. These ones are extremely nice. There's a lot of good options in the market though. I have another video on the subject of this particular helmet. I'm going to be welding around shade 11. Depends your eye color, has quite a bit to do with what shade you're doing as well as the amperage that you're running at. Alright, I have the machine set up on 120 volts, which is what you're going to have at most houses. It is on a 20 amp circuit, and I'm using 12 gauge extension cord. We're going to be running this butt joint. This is 3/32 sheet metal here and about 14 gauge tubing. And I'm going to try to run a continuous bead, and you can see how it turns out and how the machine performs on 110 volts. So we'll see how this goes. Alright, so definitely a nice long bead ran on 110 volts and 120 I mean, and it ran it perfectly well. I am incredibly impressed. I'll show you the settings we have for the weld, just so if you want to replicate it. So let's take a wire brush and we'll show you a close-up. Pretty decent. Could have turned up maybe the wire speed just a hair or the voltage, and just a little bit higher than normal. Could go up a little bit more on the voltage. We run a little faster. This thing is like a dream. So I think for 120 volts, it's doing a really good job. I dialed in the parameters a little bit more, and I think I got it even a little better adjusted here. So I'm very impressed with the MIG welding characteristics, which I think is primarily what they had in mind when they made the machine. But it does run 7018 and 6013 very well. Here I'm running a 3/32 7018 on the inside of a bandsaw part that I'm building, and I think it ran extremely well. In the shop, especially on the 240 volt, it definitely handles stick welding even better, which is not surprising. So now I've been running the machine on self-shielded flux core wire, and I find that works extremely well on galvanized material. This is all galvanized thin wall tubing, about 1.6 millimeter thick, and I'm building a chicken house. And I did a whole lot of flux core welding, and it did an excellent job. It was really convenient because I was out in a breezy area where the shielding gas would have blown away anyway. But as you can see, it did a nice job. We end up grinding and painting just the welded areas, and we leave the rest unpainted, and the chickens seem to be pretty happy with it. So here again, we're using the self-shielded flux core to put together lightweight bar joists. These are 10-foot span. They're made out of some galvanized 1x2 tubing, some 3/8 bar for the bottom cord, and then 1/4-inch bar to fill in. As you can see, we're making the W's and adding some vertical members into it. And these carry right at 1,000 pounds, and they cost about $12 in materials. They're quite labor intensive, so if your labor costs really high, probably not worth it. But I thought it was kind of fun because they remind me of how the old airships were put together. They probably weren't built out of steel, of course, but a similar concept of bar joist. This is 030 wire, which is excellent for the thin wall tubing. If you're planning to weld thicker material, you might want to jump up to the 035 or 040 flux core wire, just depending the scenario of what you're doing. But I was extremely impressed, and I'm definitely going to be doing a lot more flux core welding in the future with convenience. Here we're back to solid wire and welding on some 1/4-inch material, and the machine ran it extremely well. Doing outside corner joint, and then here a butt joint. So yeah, overall, I really like the machine. I love that it has the larger 11-pound capacity spools, and it worked pretty well stick welding to do installations in the field. It will also run a spool gun for doing aluminum welding. I recently purchased one, but I haven't had time to try that out. One thing to definitely keep in mind with these machines is that you kind of are buying at your own risk. If the machine doesn't work or breaks, often they won't do a whole lot about it, especially if it's not within like the first 30 days or whatever, that you can return it to Amazon or wherever you purchased it from. So you might be wondering, with that in mind, should I still purchase one? And it is sort of a Russian roulette with these Chinese machines, but you don't always get that much better service paying a whole lot of money. I purchased an ESAB machine that cost me around $3,000, and recently it wouldn't turn on. I called the company and they won't do anything about it. They won't help with parts. They're like, everything's obsolete, we're not going to do anything, it's your problem, and they threw me under the bus. And I think I had 100 and about 20 or 30 hours on the machine, so I divided it out. And this machine here that we're using, if it ran 11 hours and then broke, it would still have cost the same amount of money per hour. And this machine has lasted well beyond 11 hours of welding. So overall, you don't know for sure how long the machine's going to run, but in my case, this machine is so much cheaper to operate than these super expensive machines. Of course, I didn't show you any TIG welding, but for the most part, lift TIG is not super demanding of the machine, so I'm quite sure it'd do a very decent job of doing lift TIG. Well, thanks so much for watching. I hope you found this video helpful and informational. If you have any questions, leave them down in the comments below. And the affiliate links, if you're interested in purchasing the machine, will be there as well. I'm going to leave a whole bunch more video of the different welding we were doing with the machine. If you want to just see a lot more of the weld shots, you can do that. And if not, this is most of the information that I had to cover through the video. So you guys have a great day. Thanks for watching.
wrinkles. Yeah, you don't get to see much of the finished weld.